Page 468, example 1. Helen wants to display the lengths of 15 fish she caught this year to compare to the lengths of fish she caught last year. How can she use the data to make a box plot? So a box plot shows how data values are distributed using medians, quartiles, minimum values, and maximum values on a number line. So what they're doing on example 1, there's a table here with the lengths of fish. They took those numbers. First of all, they took the numbers and put them in order. And then they found out what the median was. Obviously, we can look easily and tell what the minimum and the maximum numbers are. And then they found the first quartile and the third quartile. Again, the first quartile, 13 was the median, this 113 here. Below that median, there are 7 numbers. So if you look at the numbers below that median, and you find the median of those 7 numbers in this case, that's 10. So 10 is our first quartile. And then if you look at the numbers above the median, would be these numbers. The median of those numbers is 15, which is we call the third quartile. Sometimes instead of the third quartile, they might call this the upper quartile. And instead of the first quartile, they might call that the lower quartile. Okay, so those words can be used, or phrases can be used interchangeably. And then quartiles divide the data set into 4 equal parts. And again, each part is about 25% of the data. So example 2, the Earth Club collected enough donations online to build compost bins. How can the club record the donation information in a box plot? So here are the donations that they got. So what they did, again, first of all, they put those in order. And it may be easier to tell from the table than once we write them out. You can see there's 6 in the first column, 6 in the second column. That's a total of 12 different values. So if you have 12 values, what that means is that's an even number. Means we don't have just one middle number, do we? There's 2 middle numbers here. Okay, so 12, if you split it up, you can look at 6 and 6, which means our 2 middle numbers are right here, 25 and 35. So if 25 and 35 are the 2 middle numbers, we can average those out. You might be able to look at it and tell 30 would be halfway between those two. Otherwise, if not, you can add those together. 25 plus 35 is 60, and then if you do 60 divided by 2 is 30. Okay, so that's how they got the median of 30. Now what happened in this case is 25 and 35 were our 2 middle numbers, but remember 30 is our median. So when they say look at the numbers below the median, all the numbers that are less than 30 in this case are below the median. So all of these numbers are below the median. So these are the numbers I'm looking at. We'll block this out so we're paying attention with what we should be. Okay? If you look at that, then there's actually 6 numbers below the median. 6 numbers below the median, that's an even number again. So that means I have 2 middle numbers. The 2 middle numbers here are the 15 and the 25. So again, you can average those out. You can add those and divide by 2. Or you can think maybe what's halfway between 15 and 25, which would be 20. That's how they got that number. And then if we look over here, these 6 numbers are above the median. And so again, 2 middle numbers, which are 45 and 50. You can add and divide by 2, or if you can think what's halfway in between those two, would be 47.5 or 47.5. would be the third quartile or the upper quartile. Okay, and then once we've done that, then it's just plotting those points. Again, if you want to just put dots at those points to start with, and then you can start connecting them and drawing your boxes and your whiskers. Okay, sometimes called box and whisker plots instead of box plots. One really good thing we probably should also do here is on our box and whisker plot we should make a title. So maybe we could put donations received. And then underneath our number line we could put donations in dollars, something like that. Okay, so that somebody that is looking at this has at least an idea of what this is that we're talking about, instead of being like, I have no clue what your box plot is even telling me here. Example 3. The box plot shows the distribution of the weights in pounds of bags of donated clothing. What information do you know from the box plot? So they're just wanting us to make some observations here. So if you look at this, here's some options of things that we could make observations. And I'm just going to pull this over here so we can see it as they're giving us these answers. So one observation is we could say the minimum is 8. So the lightest bag weighs 8 pounds. We could say the maximum is 20. So the heaviest bag weighs 20 pounds. The median weight for bags is about 17 pounds. The first quartile weight is 12 pounds. And the third quartile weight is 18 pounds. Okay, just some observations that we can make from this. So if you look at the try it, ages of 12 volunteers participating in a beach cleanup are shown, and they want us to record the ages in a box plot. So the first thing we'd want to do is put all these numbers in order. And it says there were 12 volunteers that participated, so we know there's 12 numbers here. That means that we have 2 middle numbers. So there's 6 numbers, there's 6 numbers. So the 15 and the 21 would be our 2 middle numbers. So we can average those out. If you add those together is 36, and then divide that by 2 would be 18. So 18 is going to be our median. So if 18 is our median, then that means all these numbers over here that are less than 18 are the numbers we're looking for when we figure out our first quartile. So 6 numbers again, we have 2 middle numbers, which would be the 9 and the 15. So if you average those out, if you add those together would be 24, and then divide by 2 would be 12. Same thing over here for the upper quartile or the third quartile. We have 2 middle numbers again. In this case, both of the middle numbers are 21. So if you average out 21 and 21, you'll get 21. So when we work this all out, the answer should look something like this. Notice if they're going by 3s here, it just happened to work out with the numbers that we had. If you want to go by 1s, or if even you go by 5s and just mark it off, you know, like here's 5, and then maybe some smaller marks, and then a bigger mark at 10, and so on. Again, these are ages of volunteers that participate in the beach cleanup. So we could then also put a title, and then underneath it we would put maybe ages. So the key concept just recaps what we've talked about here. Box plot shows the distribution of data values on a number line, and it's a good visual of what's happening. And again, it's into 4 equal groups. Each section is about 25% of the numbers, or 25% of the data in it.